Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. And then the 5th of the 5 fundamentals of RF you must know for wireless LAN success is analysis. So all this other stuff we've talked about, channels, RF interference, RF measurements, all of these things, we need to understand, how do we look at it? How do we analyze it and see what's going on in our environment? Well, the answer to that at the pure RF level is something called spectrum analysis. With spectrum analysis, or a spectrum analyzer, we can actually capture the RF energy and represent it in a lot of different ways. On the screen here, you can see the MetaGeek Channelizer and the Wi-SPI DBX adapter that's used with it. And you can see AirMagnet Spectrum Expert and the Spectrum adapter that's used with that. These are 2 very popular tools today because they're still updated and maintained, and you can still buy the devices to do the spectrum analysis. And they operate, of course, in 2.4 and 5 gigahertz. So what they'll do is they'll show you the frequencies in fast Fourier transform mode, which is where I like to say it like this: think of it as if the waveform is coming right at you and you're looking at the individual frequencies and what's being modulated on them. And then you can also see things like swept spectrogram and these types of views that are going to show you the RF energy over time in visual representations, usually using color to represent the strength of the signal. So if you're having what you think might be interference problems because of high retry rates or something like that, a spectrum analyzer will show you devices that are not 802.11, whereas a protocol analyzer is only going to show you 802.11 frames. With a spectrum analyzer, you can see video devices, you can see cameras, you can see phones, you can see microwave oven interference, you can see motor interference, anything like this that might be radiated in the environment. And you can also use them to move around until you find the signal is at its strongest to find the area where the actual radiator exists.